On the third page of your notes packet are three really important concepts. They are so important that I put them in my own words in paragraphs that I think you should pay particular attention to. Number one, a confounding variable in an experiment is a variable that is associated with the explanatory variable and influences the response variable. Because the effects of the explanatory variable and the confounding variable cannot be separated, it is impossible to tell which one of the variables, or a combination of the two, caused the change in the response variable. The results of the experiment are therefore worthless. So you can see this is an important thing to avoid. So here's an example using our tomato plant experiment. Let's say when Miss Green Thumb planted her tomatoes, the only plot of land available had a tree on one side of it. So part of the day, this plot of land maybe got, this side of the plot maybe got a little more shade than the other side of the plot did. This side got a little more sun. So I'm not saying the sun's coming from this angle necessarily, because then the tree wouldn't make a difference. I'm just saying this side got more sun, this side got more shade. Now let's say the three treatment groups that were planted over on this side of the plot were the three groups that were not pruned and had either 0 or 1 time fertilized or 2 times fertilized. And this group were the ones that were pruned with the different amounts of fertilizer. And let's say you can tell kind of by the tomatoes that I drew in here that this plot of land had on average more tomatoes than these three groups did. So Miss Green Thumb could think, oh, my pruning helped. Pruning made the tomato plants have a higher yield. But she could also say, oh, the tomato plants that had more sun had a higher yield. So which is it? Well, you can't tell. The results are confounded. The confounding variable is the amount of sunlight. The way that the explanatory variable of pruning is tied to the confounding variable amount of sunlight is that pruning is associated with more sun and not pruning is associated with less sun. You can't separate the two, so we can't tell whether or not it was the pruning or the sun that actually caused the increase. So this is the issue. We cannot tell if the amount of sun or the pruning or both together caused the increase in tomato yield. How could we fix this? Well, we could plant the plants differently. Right now we have the treatments are horizontally or vertically placed so that certain treatments are closer to the shade and certain treatments are closer to the sun. As a matter of fact, it would really be hard to differentiate between the amount, whether or not the fertilizer actually made a difference, because notice all the lower amounts of fertilizer are closer to the shade and all the higher amounts of fertilizer are closer to the sun. So even fertilizer would be confounded with the amount of sunlight. But if we planted all of our treatment groups in horizontal rows instead of vertical rows, each treatment group would have a variety of sun and shaded plants. So as a group, they would have a little of every type of sunlight. So planting the treatments horizontally instead of vertically would fix the problem. The second big idea here, and let me pause for a moment. The second big idea is the purpose of random assignment. Why do we randomly assign experimental units to treatments? And I highlighted this because it is so important. The purpose of random assignment is to spread out the effects of unknown variables in the experimental units as evenly as possible among the treatment groups so that any difference in the response variable can be attributed only to the treatments and not to a possible confounding variable. If we move to the next page, we'll see a little bit more about the purpose of random assignment, said slightly differently here. Random assignment tends to balance the effects of uncontrolled variables so that the differences in the responses can be attributed to the treatments. So let's go back and kind of think about this a little more. Let's say that Miss Thumb forgets to randomize and she doesn't randomly assign her plants to the treatments. Also, by the way, page 241 and 242 talk about another example, which I'll mention in just a moment. Really, really important information on page 242. Read it carefully, including the little blurb about replication in the margin. Okay, so let's say that, and I want to kind of cover up my sidebar here so that we're only seeing part of this at a time. Okay. So let's say Miss Thumb forgets to randomize, and she has all of her plants in containers, like they're called flats, you know, with the little, if you've seen plants from a store, they have little compartments, and each plant's in its little compartment, but they're in a big group called a flat. So she has her 2 flats of 6 plants each from Lowe's and 2 plants of 6 plants each from Menards, 12 plants altogether from each store. And let's say she just has them laid out in a row like this, and she just starts picking plants out of her flats and putting them and planting them in each of the treatment groups. Well, she would end up with all of her Lowe's plants in treatments 1 through 3 and all of her Menards plants in treatments 4 through 6. So if remember, those are the unpruned and these are the pruned. So if the unpruned plants tended to do better versus the pruned, okay, so let's say sunlight, the whole sunlight confounding issue has been taken care of, and so we don't have that issue. But let's say, for example, that the unpruned plants tend to do better than the pruned ones. Could she conclude that the pruned plants do better? Well, she might also conclude that, oh, maybe the plants from Lowe's were just better plants to start with. So once again, that unknown difference between stores might affect the plant yield. Randomizing would distribute those differences to all treatment groups. So whatever differences might be there between Lowe's and Menards would just be evenly mixed up within the treatment groups. And so they wouldn't influence one group more than the other. So if we happen to have some bad plants from Lowe's and better plants from Menards, those bad and good plants would be sprinkled among all the treatment groups, so that wouldn't overall affect what the treatments are doing. Now, if you knew in advance that, if you suspected in advance that Lowe's and Menards would have very different plants, or that might be a possibility, we could do something called blocking, which we'll talk about in the next video. Okay, last thing is, what is a control group? So let me just do this. Get rid of this. The purpose of a control group is to provide a basis of comparison between experimental units receiving treatments and those receiving no treatment at all. A control group is a group that is not receiving a treatment. So if you're talking about these plants, that would be the group of plants that's receiving no fertilizer and it's not being pruned. Now, why do we need a control group? We don't always need a control group, but sometimes it's important because sometimes a change in the response variable could occur without any treatment at all. In that case, it might appear that the treatment caused a change that would have happened anyway without the treatment. A control group allows the researcher to see if a treatment caused more change than no treatment at all. So think about our tomato plant example. So recall Miss Thumb is comparing her tomato yield to last year's tomato yield. What if this year is just a better year for tomatoes and she would have gotten a higher yield anyway without pruning or fertilizer? A control group will give her that information and then also tell her if pruning and or fertilizer increase the yield more than doing nothing at all. Okay, so she needs a group that tells her what would happen to the tomatoes when she does nothing at all, so she sees if that might have also improved yield without doing anything. Okay, so control groups are really important in this case. Now, if she's just comparing the yield from maybe one variety of tomato to another, she wouldn't need a control group because she doesn't really compare. She doesn't want to know if the yield is better than last year. She just wants to know if one tomato plant does better than the other kind of tomato plant. So she wouldn't need a control group in that situation. But since she's comparing the yield to last year, she does need to see what would happen to the yield anyway, just because of the growing conditions this particular year. So the control group is a valuable piece of information. So make sure if you're asked to discuss a control group that you understand what a control group is and what its purpose is.